Alright, hey guys, so today on section 6.3 we're going to be looking at a special type of exponential, two actually, exponential growth and exponential decay. So we're used to looking at exponential models, alright, we talked about in the past couple classes that look like this, okay, where the A represents the initial value, okay, and we also talked about how that's the y-intercept, and the B we said was the common ratio, right? But when we talk about exponential growth, all right, we're going to look at specifics for these. And to grow, right, the common ratio needs to be greater than 1. The reason being is because this is what causes our numbers to get bigger, right? Remember, we said B is the pattern. Okay, this is what determines what happens next in those exponential functions. And so in order for it to be a growth, in order for the numbers to get bigger, your B value has to be greater than 1. Okay, so today we're going to look at setting up problems for exponential growth. And to do that, okay, we need to recognize that first off, the A is still going to be the same thing. It's still the initial value, or the y-intercept. But to get that B value greater than 1, we're going to look at something called the growth rate. And that growth rate is the percent, okay, it's the percent that our initial value increases. Okay, so we're going to look at this first example here that says the population of a town, all right, it's Hillville, is 5,000 people, and it grows at an annual rate of 15%. We want to write an exponential growth model, right, to represent the situation. So there are three key things that we need to look at. First, the fact that it says grows indicates exponential growth. All right, and as soon as we recognize exponential growth, that indicates that we're going to use the f of x equals a times 1 plus r to the x. That indicates that we're going to use this formula right there, right? What the growth is going to tell us. Next, the 5,000, right? That represents our initial value. That tells us how many people are in the town at the start. And then it grows at an annual rate of 15%. Okay, that means our r is 15%. However, whenever we use that in this formula, we always want to convert it to a decimal. Okay, and so remember, 15, the decimal is right here. To convert that to a decimal, we move it 2 places to the left. So the decimal is 0.15. So now we're going to take our exponential growth equation, f of x equals a times 1 plus r to the x. Okay, and in this case, the x, right, represents our time, whatever the time that is. And so because we're talking about an annual rate, x represents time in years. Right? So we're going to fill it in. We're going to say f of x equals my 5,000, 1 plus the decimal, 0.15 to the x. Right? Now this is good, but we can still simplify it a little bit further. And we can say 5,000. This will give us 1.15 to the x. Now the reason why we call this a model, right, is because it represents the population at any specific time. So if we wanted to find the population at 5 years, 10 years, 12 years, 30 years, all we would do is plug in that number for x. So when we look at B and it asks what will the estimated population of Hillville be in 5 years, okay, all we do is we plug 5 in. Right, so we're going to evaluate f of 5. All right, we're going to take this equation that we just made and we're going to say 5,000 times 1.15 to the 5th. Okay? So from here, we're simply just going to take this and we're going to plug it into the calculator. So remember, we're going to say 5,000 times 1.15 exponent 5. Okay, And in 5 years, the population is going to be 10,056.8. Now, last time I checked, we can't have 0.8 of a person. And so because we're talking about people, our answer is just going to be 10,056 people. That's going to be the population. So we actually have to round down because it's not possible to have 0.8, and we don't yet have that full person. So we'll say 10,056. Okay? All right, let's look at another exponential growth. Okay, so we look at this. It says the initial value is 1,250, and it increases at a rate of 25%. Write an exponential model to represent the situation. So initial value is 1,250. Increases. That tells us we're going to use f of x equals a times 1 plus r to the x. Okay? Now, the initial value, it tells you right there, a is 1,250. Okay? The rate is 25%. Okay? We want to change that to a decimal. So my decimal right here is at the end. If you don't see a decimal, it's always right here at the end of the number. And we're going to move it 2 places to the left. Always 2 places. Right? So the decimal is 0.25. Okay? So now all we have to do is plug these in. So 1,250, 1 plus 0.25 to the x. So our final model is 1,250 times 1.25 to the x. Right? That's it. Right. Now we can go down to part B, and we can find the value when x is 16. So we find f of 16. It's 1,250 times 1.25 to the 16. We put this into the calculator. 1,250 times 1.25 to the 16. And we end up with 44,408.9. And this one, because we're not dealing with people or animals or anything, we can go ahead and just keep the decimal. 44,408.9. Okay. All right, now that's exponential growth. When it's increasing, when it's growing, we use 1 plus r. So if you flip over to the back, or the next page, all right, this one's dealing with exponential decay. The only difference between exponential decay, the a still represents the initial value, right? But the b, still the common ratio, but the common ratio, this b value has to be less than 1 and greater than 0. So it has to be a decimal, right? And to get that, we're going to start with 1, but we're going to subtract the decay rate this time. Okay, and so instead of adding a number, we're going to subtract from 1, so that way that number is less than 1, right, to give us that b value less than 1. So for exponential decay, this first one, it says Amelia posts a video that gets 8,192 views on the first day. The number of views decreases by 25% each day after that. Write an exponential model to represent the situation. Okay, so first off, right, it decreases. This tells us that it's decay. Okay, the 8,192 views on the first day, that represents our a value. That's the initial value. Okay, 25%, that's your r. Okay, so decay, that tells us that we're going to use this equation, a times 1 minus r to the x. So we need to know what our a value is. A, the initial value, that's what the a is. It's 8,192. R is 25%. Okay, we need the decimal though. So the decimal's at the end right now. We need to move it 2 places to the left, which is 0.25 to get the decimal form. Now all we do is plug it in. F of x equals 8,192, 1 minus r. Okay. We're going to simplify in the parentheses. 1 minus 0.25, okay, is 0.75. Okay. That's your exponential decay model. Now we can use that to predict after a certain number of days how many views Amelia's post will get. So the question here is asking us how many views will she have after 10 days. So we're going to evaluate f of 10. It's 8,192 times 0.75. My x is 10. All right, and we put that into the calculator. 8,192 times 0.75 to the 10th power. We get 461.32. All right, but it's not going to be possible for her to have 0.32 views, so we're just going to say 461 views because she hasn't completed that view yet. Okay. All right. Okay, moving on. For C, suppose the number of views decreases by 20% per day. How does the equation change from above? All right, so the only thing that changes from above is the rate. Okay, so we're still going to use the exponential decay model. A times 1 minus r to the x. My A value, okay, is still 8,192, but this time my rate is 20%. So when I get the decimal, 2 places to the left, it's 0.2. All right, my A value is still 8,192. We say 1 minus 0.2 to the x, and we get 8,192. 1 minus 0.2 is 0.8 to the x. Okay, so this time, notice the only difference in these, we still have the same initial values, right? But this one we had 0.75 in our parentheses. This one we have 0.8. Okay. Now the last part here, it asks us how many views will she have after 4 days. Okay, so we're going to take our new equation. We're going to plug in 4, f of 4. So 8,192 times 0.8 to the 4. All right, sorry, I just rewrote that. We got to put that in the calculator now. All right, so we get 8,192 times 0.8 to the 4th, and we end up with 3,355.44. Okay, not possible for us to have 0.44, so we say 3,355 views. Okay? All right. We've got one example where we're just going to compare growth and decay. So go ahead and flip over to the last page. We're going to go ahead and skip the one up at the top, but I want you to see the difference between exponential growth and decay right next to each other. All right, so Rich is comparing the cost of maintaining his car, all right, which most of you guys, none of you guys have cars, but as your car gets older, the cost grows. It goes up, right? But the value of your car actually goes down. So we're going to look at those two things here. All right, we're going to write an exponential model for both. So the actual value of the car, right? Rich bought it for $20,000, and every year it decreases in value by 15%. So because it decreases, the value of the car is going to be an exponential decay. But the maintenance cost, the first year, he spends $500 on maintenance, right? And that increases by 28% each year. So this is going to be growth, right? So this one is decay because it decreases. This one is growth because it increases. So here, the initial value of the car is $20,000. So that's going to be our A. The rate is 15%, but as a decimal, we put 0.15. All right, and so we end up with 20,000. 1 minus 0.15 is 0.85 to the x. Okay, so this right here is the model to represent the value of the car, right, where it's decay. This one, f of x equals the initial maintenance cost when he first starts is 500. Okay, the rate at which the maintenance increases is 0.28 or 28%. We simplify this, we say 500 times 1.28 to the x. And this right here is your model to represent exponential growth. Okay? All right, you guys have a worksheet to work on that's going to be due by the end of class. All right, it's problems similar to this. Okay, so make sure you're working. You can ask the sub to replay this if there are any notes that you didn't get, and you guys can just get to work. All right? We'll talk about these a little bit more next class, which I hope to be there.